This talk is on types of chemical reactions. So this plays into the role as far as acid-base reactions that we've talked about, and there's a whole host of other types of reactions. So let's get started with this. There's really 5 types that I'm going to talk about that we're going to use in this class, and those 5 types are here: synthesis, decomposition, single displacement, double displacement, and combustion. Sometimes instead of displacement, we use the term replacement as well. So those are the same type of reaction. So if you see that in another textbook or other things that we do, that's the same type of reaction. Now, you'll need to be able to do 3 things. First is identify the type of reaction, balance the reaction, and predict any products. And by the time we're done with this, you'll have no problem with this. It sounds like a lot right now, but it's really not too bad. The first one is a synthesis reaction. So typically what we do with these is there's 2 substances, and they combine. So for example, we might have a reactant here, and we make one product. So this might be an element A plus element B gives us the product or the compound AB. A great example is hydrogen with oxygen produces water. Another example is carbon and oxygen, which produces CO2. So that's a synthesis reaction when we're producing something. Now, here's an example with potassium and chlorine. We'll do some examples in class and some labs with this as well. So some practice questions here. If you're going to predict the products for these, sodium solid plus chlorine gas, well, naturally if it's a synthesis, it's going to be sodium chloride, NaCl. Now, the hard part about some of these sometimes is balancing them. So it's pretty easy to predict this because sodium is +1, chlorine is -1, so that's a naturally balanced formula. However, there's still 2 chlorines on this left side over here. So what we need to do is to balance this is we need to put a 2 here and a 2 here. And we worked balancing a lot earlier in the year, so we're revisiting that a little bit. The next one is solid magnesium with fluorine gas. So magnesium, Mg. This is a 2+ ion, and fluorine is a -1 ion. So in the formula, when we cross multiply these things, so Mg is a 2+, fluorine is a -. So what that means is we take this -1 and we make that magnesium's formula number. We take this +2 and make that fluorine's number. So we're going to have the formula MgF2. So I'm going to put a 2 down here. And again, this reaction is actually already balanced, so we're done. The last one is aluminum with fluorine. So aluminum, from your periodic table, it's Al3+. Fluorine, again, is -. So when we do the crisscross rule, this comes down here. So it's aluminum 1. This 3 comes down here. So fluorine is 3. So our formula is Al(F)3. So that's going to be our product here in the synthesis reactions. So that's synthesis, we're done. Decomposition is next. So decompositions are breaking apart reactant into 2 products. So typically the compound breaks into elements. So for example, water can be stripped of hydrogen and oxygen to make just hydrogen and just oxygen. Mercury oxide is another example. We can make just mercury and just oxygen here. The really important part with these reactions is that, remember the diatomic gases, hydrogen 2, oxygen 2, Cl2. Basically, any of the gases from the periodic table are diatomic. So those, when you write and predict, you need to keep those in mind. Here's an example, and again, we'll do some of these in class, so I'm going to skip over that. There's a few exceptions to this rule, and that are kind of consistencies. Carbonates here always break apart into carbon dioxide and then the metal oxide. So for example, with calcium carbonate, it'll be calcium oxide here. CO2 will always be present when a carbonate breaks apart. So it'll always break into carbon dioxide and a metal oxide. Chlorates do something similar, except they always decompose into oxygen gas. O2 is always present. And then the other part of that is what we call a metal chloride. So it's going to be a metal here, whatever that metal is, but then there's going to be a chloride attached to that. So these are special cases. We won't explore these a whole lot. We will do, I think, this carbonate maybe as one example in the lab that we'll do. Now, just a few practice ones. If you want to skip over these, you certainly can if you understand this. But basically what we'll do is we'll take lead oxide and break apart that compound. So what we break it apart into is Pb plus oxygen's diatomic, so it's O2. So then we check to see if it's balanced. There's one lead here, one lead here. There's two oxygens here, two oxygens here, balanced. The next one is aluminum nitride. So we're going to break this apart into aluminum plus nitrogen. Nitrogen's diatomic, so it's N2. So now to balance this, there's one aluminum on each side here, but there's two nitrogens on this side, and there's only one over here. So naturally we need to put a 2 here. So now we have two aluminums, two nitrogens, which means we have to put a 2 here also. So now we have two aluminums, we have two nitrogens, and we have two aluminums and two nitrogens on this left side also. So the balancing of these are really pretty easy compared to a lot of the balancing ones we did earlier in the year. Not too bad. So that's synthesis, decomposition are done. Single displacement is next. Single displacement is where you take an element, and that element gets inserted into a compound. And so zinc will replace copper in this case. So what we do is switching the cations is the most common form of this. So instead of having copper CuCl2, now we have ZnCl2 for our compounds. So with this table, this chart is really important. There is an activity level or a level of activity that's really important. So these ones are highly active, and these are low activity. What that means is that anything up here will replace anything below it. Will replace anything below. So for example, lithium would replace sodium. Magnesium would replace nickel. Nickel would replace hydrogen if they're in a reaction together. So the least active is gold on the bottom, platinum very unreactive, silver unreactive. That's why they're kind of precious metals. Whereas these top ones are very active and replace and are constantly in chemical reactions. So predicting the products, here's 4 examples I'm going to go through. If you want to look at one of these, you certainly can, but this might take a little bit longer on the presentation. So here's the first one. What we want to look at is silver here. Silver is +1, which is going to replace the sodium. So that's going to come in here and knock this guy off. So we're going to get silver chloride plus sodium. Now just to double check that that is true, we have to look at our activity series over here. So which one is higher up and which one would work? So as a result of that, if silver here is higher, then it will work. If it doesn't, then the sodium will stay there. So for example, here is silver and sodium, here it is. There's sodium there. So of those two, the more reactive one is going to be sodium. So that's going to stay where it's at. So in this case of this reaction, the prediction says that you're in green, no, this will not work because sodium is more active. It is higher on the chart than silver. So this one will not work. Here's another example. Calcium and sodium. So now let's look at these. Here's calcium up here and sodium's right below it. So of the two, the more reactive one is calcium. So calcium will, in this case, come here and knock out sodium. Calcium's ion is 2+, whereas sodium's ion is only a +1. So that's going to change our formulas a little bit. Calcium, being a 2+, interacts with this phosphate, PO4. Phosphate is 3-. So now make sure to put parentheses around this. We're going to do the crisscross rule. So that means there's going to be 2 phosphates, so PO4, 2. And this 3 over here is going to be the subscript for calcium. So it's going to be calcium 3, PO4, 2. That's our first product. The other product that we're going to get is this sodium needs to go somewhere. So that's going to be over here by itself. Now I'm going to erase this a little bit here. And what I'm going to do is we need to balance this now. So in the case on the right side, there's 3 calciums. So the first, let's do phosphate as a group first. So the phosphates, there's 2 over here. And there's only 1 here. So we need to put a 2 subscript here. The next step is let's balance the sodiums. There's 3 times 2, so there's 6 here. There's only 1 over here. So let's put a 6 out in front. So now those are balanced. And then the last part is just doing the calciums. There's 3 here. There's 1 here. So 3 needs to go in front of there. And now we're balanced and we're done. Here's another example. So if you want to take some time to do this, go ahead. Pause it now. And then I'll show you how to do this. So the first part of it is zinc and hydrogen. Which is more active? The more active one is up here. So zinc should replace the hydrogen in the hydrogen chloride. So what we'll get is zinc is generally a 2+ ion. Hydrogen's a +1 ion. Chloride's a -1 ion. So in our formula, we'll have ZnCl2. And our other product will be hydrogen. Remember, hydrogen's diatomic, H2. So now to balance this, I'm going to do that in green. On the right side here, we have 2 chlorines. Here we only have 1. So we need to put a 2 here to start with. Now that gives us 2 hydrogens. There's 2 hydrogens here. There's 1 zinc and 1 zinc. So we're all balanced up now at this point. The reaction works, and we have our products. So zinc chloride and hydrogen gas. The last one here, this is a reaction between, this is gold and this is copper. So gold is down here, copper is down here. And so this is a way for us to extract gold if we had a solution of gold chloride. So AuCl3. So what we do is copper will replace it. It's higher up. So we're going to have, let's see, copper is, let's say, 2 a plus ion. So that means it's going to be CuCl2 plus the gold ion. And so copper chloride, let's balance this now. There's 3 chlorines here and 2 here. So what I'm going to start by doing is putting a 2 in front of this one up here. So that gives me 2 golds, 6 chlorides. So now in this case, I need this to be 6. So I need to put a 3 here. Now I have 3 coppers, so I need to put a 3 over here. I have 2 golds from this left side, which means I need to put a 2 here. So my final is 2, 3, 3, 2 for my balanced reaction. So that is single displacement. One of the longer ones takes a little bit of practice time. Decomposition reactions and synthesis reactions, we've covered those three. Double displacement, this one really pertains to the acids and bases, but basically this is the same as a single replacement. What we're doing is we're switching cations. So here we have magnesium oxide and calcium sulfide. Those two are going to exchange, which makes it magnesium sulfide, calcium oxide. So we have four compounds, two compounds as products, two as reactants when we're done. So most of these examples, you don't have to really check to see for sure if the reaction works. We just assume that some of it does react. So that's going to be a little bit different than the previous slide. So in this case, we're going to just exchange hydrogen and silver. They're both positive 1 ions, so nothing's going to change too much for formulas. So we're going to have hydrogen, which is a positive 1, nitrate, NO3, which is a negative 1. So that formula balances, plus silver chloride, which is a balanced formula as well. So these are predicted. We've done that. We've exchanged the two ions. Now we've balanced the equation because we have the same number on both sides. Example 2, a little bit more complex now. We're going to exchange calcium and sodium. So calcium is a 2+, sodium is a positive 1. Phosphate for my periodic table is a 3-, and chloride is a -1. So we're going to get our first product is sodium chloride, NaCl. And since this is positive, this is negative, it's balanced, the formula is balanced the way it is. The other formula will be calcium phosphate. Now, to determine again how many subscripts you have, you take calcium, which is a 2+, you have phosphate, which is a 3-, and you do the crisscross rule. That becomes the calcium subscript. This becomes the phosphate subscript. So we get Ca3PO4 parentheses 2. Okay, now to balance out the reaction. What I like to start with is the phosphate groups because polyatomic ions generally are the ones that give you the most trouble. So what I'm going to do is I'm going to start with, I have 2 over here on this side. I'm going to do this in green, so I have 1 here and 2 here. So let's balance that up, give me 2. So now I have 2 phosphate groups. I have 6 sodiums. So let's take care of that one next. So if there's 1 sodium here, I need to put a 6 out in front. That gives me 6 sodiums, 6 chlorides. Now if there's 6 chlorides here, and in this formula there's 2 chlorides, I need to put a 3 out in front. So that gives me 3 calciums, 6 chlorides, and I should be balanced. So there's predicting and balancing. Another example here. We have lead, Pb, and chloride. And then the other formula will be barium nitrate. So let's go back and look at the charges here. 2+ on barium, -1 on chloride. All I've done so far is exchange these 2 ions. Nitrate is a -1. This lead is a +2. So when I exchange these, the formulas don't really change. Lead is 2+, chlorine is -1, so I'm going to need 2 chlorides. And same thing over here, we have a minus and a +2, so I'm going to need 2 nitrates. Okay, if you look at this, it's already balanced. There's 1 lead on each side, there's 1 barium on each side, there's 2 nitrates and 2 chlorides on each side. So we're done. Next example. What we're going to do is exchange the sodium and the iron here. So iron is a 3+ ion. Hydroxide, OH, is a minus polyatomic ion. So I'm going to need 3 of those to balance out the positive charges here. I'm going to have sodium chloride as my other compound. There it is. And now I need to balance these. I have 3 hydroxides, so let's put a 3 out in front here. I have 3 chlorides here, so let's put a 3 out in front over here. So now as a result, I have 3 sodiums, 3 chlorides, 3 hydroxides, 1 iron. So here I have 3 hydroxides, 3 sodiums, 3 chlorides, 1 iron, and I'm balanced. The next practice one here is sulfuric acid with sodium hydroxide. This is one I'm going to skip over because this is actually an acid-base reaction I'd like to talk about in class. Here's one more example I will do. We take potassium and copper and exchange those two. Potassium is +1, copper is +2 in this case, sulfate is -2, hydroxide is -1. So we're going to have Cu +2, hydroxide OH, which is a -1. So we need 2 of those, plus potassium, which is a +1, and sulfate, SO4, which is a -2. Now, I need 2 potassiums here to balance that out. So let's start balancing formulas then. There's 2 K's here and 2 hydroxides, so all I need to do is put a 2 in front here. I have 2, 2, so 1 copper, 1 sulfate. There's 1 copper, there's 1 sulfate, and I'm balanced. Okay, so that's the 4 big ones. Combustion reactions are another one. This one doesn't take long at all. The biggest thing to remember with combustion reactions is that we always get these as products, carbon dioxide and water. So here's an example of methane. In combustion reactions, you also have oxygen as a reactant. So these 3 parts will always travel together. You'll always have oxygen as a reactant, carbon dioxide and water as products. So oxygen as a reactant, carbon dioxide and water as products. So here's just an example of a combustion reaction. We have C5H12O2 CO2 H2O. And so if we're going to balance this, there's some of these can be a little bit longer and take a little bit longer time. What I would suggest starting off with is doing carbon first, then hydrogen second, and oxygen last. Because you can always adjust this term here. And so let's do one example here. So for this one, I'm going to draw, actually on each side, carbon, hydrogen, oxygen, carbon, hydrogen, oxygen, because it helps me to count. So right now I have 5, 12, and 2. Carbons, I have 1, I have 2, and I have 3. So I'm going to start with carbon. So I need to multiply this by 5 to give me 5. So I'm going to put a 5 in front here. That also changes my number of oxygens. So now I have 11 oxygens. So the next thing I'm going to do is hydrogen. There's 2 here, and I need to multiply that by 6 to give me 12. So I'm going to put a 6 out in front here. And so that changes the number of oxygens I have. So now I have 10 oxygens here, 10 O's, and 6 O's over here. So I have 16 oxygens, and I only have 2 over here. So 2 times 8 will give me 16. So to put out here, I need an 8. And then we're done with balancing. Here's a bottom question. Write the products and balance following combustion reaction. So with this one, the products are always going to be CO2 plus H2O. To balance this one now, I'm going to balance it using blue, I think. So carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Carbons over here, I have 1. Hydrogens, I have 2. Oxygens, I have 3. Carbons here, I have 10. Hydrogens here, I have 22. And oxygens here, I have 2. So let's do carbon first. I need to multiply this by 10 to give me 10. So I put a 10 in front here. That changes the number of oxygens I have. So I have 21 now for my oxygens. And I still have 2 hydrogens. So let's do hydrogen next, and you'll see how easy this is here in a second. 2 times 11 will give me 22. So I put an 11 out in front here. That also changes the number of oxygens I have. So I had 20 now here, and I have 11 from here. So I have 31 oxygens. So coming over here, in order for me to get this to work, I would have to multiply this by 15.5, which is 31. Now I cannot do that because I can't have 15.5 here. So if you ever come across this case, you take everything that you have for this, the coefficients. So this is actually a 1. This is 15.5, 10, and 11. All you need to do then is multiply it by 2. So this becomes a 2. This becomes a 31. This becomes a 20. And this becomes a 22. That's about the hardest balancing we can do. But if you follow the carbon, hydrogen, oxygen rule in that order, it's going to be really easy for combustion reactions. Okay, so those are the types of reactions. You need to be able to identify them based on what is being made, if it's being broken. So in synthesis, we're combining. In this, we're breaking down. In this one, we are exchanging cations. In this one, we're exchanging both ions. In combustion reactions, it's always oxygen that results in CO2 plus water. So those are the key points for the types of reactions as far as identifying them. Balancing the reaction, that's kind of up to you guys. We've done plenty of those. Predicting the products comes from the exchange or the breakdown or the combination of these ions. And so understanding which ones are which are very important. We'll spend a couple days in lab working on this. That's the end of the presentation. Make sure I know it was longer. Make sure you look at some of the examples over again if you need to. And we will do a lab when you come into class. Make sure you take the quiz.